And we are going to begin 10.3, geometric sequences. So go ahead and pull out your notes. Thank you. So similarly to arithmetic sequences, we can define it recursively. This is our recursive definition. So with the recursive definition of an arithmetic sequence, we were going to add or subtract something each time to find the next term. So if I knew the first term was 2, and I knew my common difference was 5, I'm going to add 5 to find the second term, and then add 5 to that to find the third term, and so on. What is the recursive definition telling us we're doing with geometric sequences? Multiplying each time. We're going to multiply by some value r, and r is our common ratio. So a sequence is geometric if there is a value r and r cannot be 0. Why do we have that caveat in there? 0 multiplied by anything is 0. So if we multiply by 0, we're not going to have this sequence that is geometric in nature. We're just going to have an output of 0 each time. So if there's a value of r such that a sub k plus 1 is equal to a sub k times r, the number r, which we find by dividing two consecutive terms, with our common ratio we subtracted, with our common difference we subtracted, with our common ratio we will divide. So any two consecutive terms, you will divide the one that comes later by the one that comes right before it to find your common ratio. And I'm going to put up the formula for the nth term. The formula for the nth term of a geometric sequence, a sub n is equal to the first term times r to the power of n minus 1. Or the more general form, where we can use any two terms in the sequence, a sub n is equal to a sub k times r to the n minus k. N and k have to be positive integers because they're telling us where we are in the sequence, how far along that line we've gone. Go ahead and practice a little bit with finding terms in a geometric sequence. You guys okay if I put that example up? Okay. We want to find the next 3 terms in the sequence, and then we're going to write the rule for the nth term. What do I need to know before I can write any of these terms? I need to know the common ratio. So we need to find the common ratio first. I need to take 2 consecutive terms and I need to divide them. I can pick the first and the second. Second one divided by the first one. I could pick the second and third. 45 divided by 15. Either way I do this, I get the same common ratio. What is our common ratio here? 3. So we have the first 3 terms. We're supposed to find the next 3. So what would the 4th term in this sequence be? 135. We're going to do 45 times 3, which is 135. What about the 5th term in the sequence? 405. 135 times 3, we get 405. And what about the 6th term in this sequence? Yep, 1215. 1,215. Now I want to write the nth term. How do I write this for a sub n? I heard 5 times 3 to the power of n minus 1. Yes. That is our rule for the nth term. That would be the nth term. Remember this right here, that's our first term. This right here is our value r. So far, so good? All right. Let's look at part B. What is our common ratio on part B? 1/2. R is equal to 4 over 8 or 2 over 4. Our common ratio is 1/2. So what's the 4th term in this sequence then? 1. The 5th term? 1/2. The 6th term? 1/4. Nicely done. So what's the rule for the nth term? Yes. Now, when we've got a fraction or a decimal for our R value, we will often put it inside parentheses so that it's very, very clear that that entire thing is what is being taken to the power of n minus 1. All right.
So when do we know, to use a geometric
Instead of arithmetic?
Yeah.
So when you're looking at a sequence of numbers, if they give you a sequence, you would be looking for, are they adding or subtracting a constant amount each time? Is it changing by the same value using addition or subtraction? That would make it arithmetic. If it's changing because of multiplication or division, then it's going to be a geometric sequence. So you have to have at least 3 terms, or else you don't know whether they're adding or multiplying. Good question. A geometric sequence has first term 3 and a common ratio of -1/2. I want to start off by writing the rule for the nth term, and then we're going to write out the first 5 terms. So what is the rule for the nth term? Yes, 3 times -1/2 to what power? N minus 1. Beautiful. Okay, so now using that rule, I want you guys to find the first 5 terms. They probably all need to be sharpened, honestly. First term is 3. Second term would be what?
1.5.
Yep. I'm going to write these as fractions because as we move on, if we write them as decimals, it's going to get really, really long. So I'm going to write these as fractions. When we have the option, my preference is usually fractions. If you can write it in decimal form and still be exact, then I will accept that. But don't round on these unless the directions say that you're allowed to round. We want to keep everything in exact form. I would accept -1.5 here. What would the third term be? 3/4. Or positive 0.75. What about the fourth term? -3/8. And what about the fifth term? Positive 3/16. Do you guys have any questions about how we came up with those values? You said yes? Oh, you're good? Okay. I know we're going to get through at least one more here. Yeah. I'm going to put up our next example. We're going to find the first and the 8th terms. We're also going to write the rule for the nth term. What information do we have to work with? A sub 3 is 5. And A sub 6 is -40. What information am I going to need in order to be able to find the first term, the 8th term, the nth term? I need that common ratio. Do I have 2 consecutive terms? So I can't just divide those two. What could I do since I can't just divide those to find my common ratio? Yes, a sub n equals a sub k times r to the n minus k. We have the 6th term. We have the 3rd term. We don't have our common ratio, but up here I would do 6 minus 3 because that's n and k. What is our 6th term? Negative 40 equals, what is our 3rd term? 5 times r to what power? Yep, r to the 3rd power. Where would I go from here? Subtract? Divide. We're using multiplication here, so I need to use division. I'm going to divide both sides by 5. And so I get negative 8 is equal to r to the 3rd power. What do I do now? Cubed root. Do I have to worry about pluses and minuses with a cubed root? I do not. It is negative 2. When our powers are even, that's when I have to watch out for the plus minus. So powers of 2, 4, 6, 8, that's when I have to watch out. Because like 4, if I take the square root of 4, positive 2 times positive 2 will give me 4, but negative 2 times negative 2 will also give me 4. When I'm talking about odd roots, the sign on the value that I'm taking the root of, that will be the sign on my root. So odd powers, you don't have to worry about the plus minus. Even powers, you do. All right. So now we want to find our first term. And actually, bell's going to ring here in 2 minutes, so I think we'll find the first term, the 8th term, and the nth term starting tomorrow. I have gone ahead and posted the homework. So if you want to start looking at it and maybe start dabbling around with it, you can, although there's a whole bunch that we have not talked about yet.